Okay, eager students, this is Earth Science Exploration 1.4 Measurement. All right, before we get into what we measure, let's talk about why we measure things. And there's some pretty good reasons for doing this. First off, we want to be able to plan ahead. So if you're going to be building a building, you kind of need to know exactly what materials you need, how many materials you need, and like the measurements so that things come out looking nice and flush. Okay? The other reason is, so we can have enough. Our ancestors had to plan for winter. If we couldn't measure out food and resources and materials, we wouldn't be able to make it through. The other reason is so we don't waste. When I go to a buffet, I don't put so much on my plate that I've got to throw it away because, I can measure with my eyes. We also measure so that we can compare to make sure we have equal amounts or to make sure we have more or less than somebody else. We measure so that we can communicate. If I go up to the McDonald's drive-thru and say, I want hamburgers, they're not exactly going to know how many hamburgers I want. They might give me 2. That's hamburgers. They might give me 200. That is also hamburgers. And then finally, we just measure so that we can understand the world around us. Is that big? Is it little? Is it heavy? Is it light? Is it near? Is it far? These are the reasons we measure. All right, now, how do we measure? Well, typically we measure using things we know, things that have been around us. So, for example, we might measure using our hands or our feet, rocks, pieces of rope, coins, sheets of paper. It doesn't really matter. We can really measure with anything. But the problem with doing this is that not all measurements are the same. If I'm telling you how far away something is or how long something is using my hands, it'll be different than yours because your hands might be bigger or smaller than mine, right? It's not standardized, same thing. Now, if we used one person's hand in particular, I guess we could standardize the system. And then there's unit confusion, right? I might go to a different culture or a different town and people don't measure with hands there. They measure with pieces of rope, right? And those people might measure with pieces of rope different than in another town where they use different lengths of rope. So there's a lot of problems with how we measure. Okay, so historically, every culture and group of peoples had their own system of measurement, and this has led to a lot of confusion, especially when it comes to trade, where we're taking our resources and trading them for somebody else's resources. So over time, humans developed, major systems that lots and lots of different people could actually use. Now, today there are 2 major systems still in place being used, and then, some cultures still have their own specialty systems. But worldwide, we either use the English system, also known as the imperial or standard system, and we use the metric system, which is also known as the SI or System International. Okay, so let's compare the English and the metric system and maybe see why these are both used. All right, so English system is really only used in 3 places officially: the United States, Liberia, and Burma. And Burma is currently phasing it out in favor of the metric system. The metric system is used everywhere. This is truly a global system. In fact, it is used in the United States by our United States military and in science. So some of the pros to both of these systems. The good thing about English, at least for us, is that it's familiar. And that's about it. All right. The pros for the metric system is that it's standardized. It's based on 10, which we have 10 fingers, 10 toes. So that makes it really easy to calculate and really easy to convert within the system. The cons for the English system are that it is actually really hard to convert because there is no standard base. We've got 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, and so on. So it's really, really difficult to calculate without a calculator. The cons of the metric system right now are really just that it's mostly unfamiliar for us Americans. We're just not used to using it. If I tell you how far away something is in kilometers or meters, it just doesn't mean that much to you. All right, now, to kind of further emphasize these differences, let's take a look at some of the units of measure in each. All right, in either English or metric, we measure mass, length, volume, and temperature. Let's take a look at mass. For English units of mass, we've got ounces and pounds and scruples and drams and tons and slugs and even more than that, right? And these things don't convert from one another too easily. Whereas in the metric system, we just have one standardized measure, and that's the kilogram. Now, we can have parts of a kilogram we would call a gram, or even smaller parts like a milligram, but it's still just based on one thing, the kilogram. In length in English, we've got inches, feet, yards, miles, leagues, furlongs, so on and so forth. Whereas in metric, we just have the meter, and that's it. Now, we might have 1,000 meters, which we can call a kilometer, but it's really just meters. For volume in English, we've got quarts and gallons, cups, teaspoons, tablespoons, bushels. It goes on and on. In the metric system, we just have the liter. And finally, in English and temperature, we've got Fahrenheit, which is actually a perfectly good system. It's just that the numbers aren't nice and rounded off at the tens. For example, freezing temperature is 32, boiling is 212. Whereas in the metric system, it's still based on freezing and boiling of water, but freezing is 0 and boiling is 100. All right, finally, ways of measuring. There are two major ways that we can measure. The simplest form is qualitative, where we measure with descriptions. We say something is big or small, heavy or light, near or far, tall or short, things like that, okay? But that can be very relative to the individual. Versus quantitative is where we actually attach numbers and units to it. So instead of saying near and far, I might say, it's only 1 mile or it's 1,000 miles, right? We've got a number attached to it, so it actually means something to us. All right, finally, let's look at accuracy and precision because these are often confused. So accuracy is how close a measured value, what you are measuring, is to that real measurement, okay? So we can think of this with an archery analogy. If you are accurate, you are hitting the bullseye. You are like spot on. And now this is often confused with precision. Some people hit the bullseye and be like, man, that was so precise, but that's not what it means. Precision is how close what you are measuring is to your other measurements, okay? That is, do you keep measuring a certain thing the same way? Okay, think of this as hitting the same spot on your target again and again and again. It doesn't have to be the bullseye. If you are constantly hitting the top of the target in the same spot again and again, you are very, very precise. Now, what we strive for is accuracy and precision. As an archer, I want to make sure I'm hitting the bullseye over and over and over again. That's accuracy and that's precision. Join us next for 1.5, What We Measure, Mass.